Okay, today we're going to be talking about the Pythagorean Theorem and how to apply it. Previously we said that the Pythagorean Theorem, or we proved, results from having a right triangle with sides lengths of a, b, and c. And if that's true, then we can say that a squared plus b squared equals c squared. In practice, that means if I'm given a right triangle, I can take a side length and another side length and find a missing side length. It is a right triangle, and I know that a squared plus b squared equals c squared, where c is the hypotenuse. So in this case, I would change a with 5 or 7. It doesn't matter which one of those I use. B squared is the other leg. In this case, x is my c squared. And I know a lot of times we're tempted to just cancel all those squareds, but you're not allowed to do that. Just like you can't say 3 plus x squared and just distribute that. It's not the same as 9 plus x squared. It's the same as 9 plus 6x plus x squared, because things boil out or distribute. So anyway, this is 5 squared plus 7 squared equals x squared. That's 25 plus 49 equals x squared. 74 equals x squared. Well, can I simplify that? I can say that the square root of those is valuable. Square root of that equals square root of that. Normally that would give me a plus or minus, two possible solutions. But because this is a length, all I'm concerned with is the positive. And if I wanted to simplify that, that would be 2 times 37, which is a prime number. Therefore, this is the solution. That's the precise answer. If I were looking for a decimal approximation, I would then say, what's the square root of 74 on a calculator? And I'd get that x is approximately 8.60. That's the finding of the hypotenuse. Very straightforward. In the event that I'm given the hypotenuse, for example, and a leg, I would set up the same scenario. A squared plus b squared equals c squared. It is a right triangle, and the legs squared equals the hypotenuse squared. So x squared plus 16 squared equals 20 squared. So x squared plus 256 equals 400. Subtract 256, I get x squared is equal to 144. Take the square root, and again, because I'm taking the square root of a number, I should get a positive or negative, but because I'm talking about length of a side, I can just leave it as the positive. X is equal to 12. Okay, that's a simple application of using the Pythagorean theorem to find a missing side.